Good afternoon, everyone. My name is Jimin, and I'm an associate member of the Public Information Committee of ASCB. And welcome to the webinar today titled Building Simple Microscopes for Schools, Leveraging Hands-on Activities for Effective Science Engagement. And for today's webinar, we'll have two sections. The first section will be a talk given by Dr. Bob Goldstein from UNC-Chapel Hill to talk about his experience using hand-made microscopes for science engagement. Then for the second half, we'll have a panel discussion with three panelists who all have worked on projects funded by the ASCB Public Engagement Grant with hands-on activities involved. And the three panelists we have today are Dr. Quinn All from Quyen University, Molly Gordon from Johns Hopkins Medical Institute, and Dr. Kristin Kirschbaum from the University of Toledo. And they all have great experience for hands-on activities, so we'll have a very great discussion on this topic. So for the audience, please feel free to use the Q&A function if you have any questions for the panel. You can also use the chat box if you have any comments or want to discuss on certain topics. And without further ado, let's welcome Dr. Goldstein to tell us about his journey on his workshops for handmade microscopes, and especially how he successfully reached out to public elementary schools in North Carolina, especially some low-income regions. So Bob, do you want to take over now?
Great, thank you. Okay, so I'm going to tell you how I came about doing this project, and in the course of it, I hope you'll see, one example of an outreach project that may spark some ideas for your own outreach projects. I'll also tell you that I have a website here, and anyone who wants to sort of replicate this outreach project is welcome to do so, improve it, do somewhere else, something like that. Okay, so I started this project just really based on my own curiosity. I had seen that there were lenses available for iPhones, where you could just stick a lens on a phone and get a decent microscopic view of things. And every time I would see one of these kinds of lenses, I would try it out. Some of them worked really well, but there were always some limitations to me. And one of the serious limitations was no matter what I was looking at, it was hard to get the lighting right because usually my phone was shadowing what I was trying to look at. And the other issue is that these lenses tend to have a really short working distance. Really, the focal plane is really quite close and narrow. And so it was very hard to hold things still. So that you keep things in focus. And then years ago, I saw this design on Instructables, which is a website that has protocols for all kinds of things. This guy, Kenji Yoshino, shown here, had put out instructions for how to make a simple microscope that basically took care of those two problems, right? It uses these wing nuts to adjust focal plane. So you have a fine control over Z distance between a lens and where you put your object. And it has a light that you can just pick up and put where you want, right? So the design is basically that there's a lens that's crazy glued into a hole in a piece of plexiglass. You sit your phone or something or a tablet on top of that lens. And so you look through the lens onto your object that's sitting on this piece of plexiglass, and then you can light it how you want. The parts added up to about $10, so he called it the $10 smartphone. And you can see here, I'm not the only person who discovered this, right? There's like 1.7 million views of this Instructable online. I saw this thing and I thought, I really want to build one of these just to try to use with my kids. Here are my kids at the age they were at the time we did this. I think this was around 2013. And we built one of these and I looked through it, and the first thing I did was just tear a piece of paper and look to see what it looked like on the torn edge. And when I saw this, I said, holy, I don't think I can swear on an ASCB webinar, but my kids told me to stop swearing. And I tried not to push them out of the way, but I could not believe what you could see, right? So it's clearly not as good as the labs we use in the microscopes we use in the lab. But it gets you to a world that you would not see with the naked eye. So there's just a piece of torn paper. I noticed if you took a flower petal, especially flower petals that have patterns on them, you could see individual cells, which just astounded me, right? We could be looking at cells that easily. I must confess, I don't think I had a real intuitive sense for how big a cell was until I did this, until I could see flower petals and see patterns on them and just guess like how big a little stripe or a dot was. And then you can see these patterns of cells in them. There's a red onion. You can see individual cells without red onion come pre-stained red for you, right? So this amazed me, right? I saw that and I thought, I want to do this with students. And I teach a couple of honors classes at UNC. And in the honors classes, we've got a lot of freedom to do what we want. And so in each of the classes I teach, we take a couple of days where we do something completely different than the topic of the course. And I decided we'd try to build these for a class period. So I put together a little assembly diagram and I brought all the parts and we built some of these. I did one good lesson I had in this is that it's a bad idea to do the crazy gluing in a class period where there's a limited amount of time. So since then, I do all the crazy gluing in advance, but the students can assemble them in a class period and be looking through them at stuff they brought with them. I set up a website just using Flickr to where they could upload photos. Unfortunately, Flickr doesn't allow this in the same way anymore, but there are other ways to do this that I have detailed on my website. And they uploaded pictures as they were taking pictures. So they take pictures with their phone or with their iPad. They upload the pictures right from there, and we were sharing them live. So I would project them so we could all see the pictures coming up, and we'd see something strange. And we'd say, oh, what's that? And we'd all look at those things. It was fun in that, science went from being, something that a professor or a lab brings to you to something where the students would bring things in their pockets and pull lint out of their pockets and money and look at grass from outside and bugs they found and things like that, right? It's really curiosity-driven science, which of course we all know is really powerful, right? And I think having a little curiosity-driven science in a class changes the feel of the class, even when we are presenting material to them that's not driven that way. Students now and then would come across things that I hadn't recognized at all. So for example, one of the students was looking at a penny, and on the back of the penny where there's the Lincoln Memorial, it turns out Lincoln is sitting in there. And if you look really carefully, you might be able to see it. My old eyes can't see it, but most other people can. And so they were curious, how big is Lincoln? I said, well, why don't we just take a picture of a ruler and then we'll compare, some part of a ruler to this, and we'll be able to figure out how big his head is. And so a student came back with this picture of a ruler. And I said, no, you need to get the actual millimeters. So then they took a picture. This is like 1 millimeter from one line to the next line. And we could calculate Lincoln's head, it turns out, is about 60 microns across, which to me is a really familiar size because it's about the length of a C. elegans embryo. They see things like table salt. So table salt, of course, has cube shapes because of the way sodium chloride packs together when the crystals grow. And then I'll just show you one other picture taken by a student that I think is my favorite picture a student in a class has ever taken, which is this. This was in winter, and they had a black mitten, and of course, the light would not go through the black mitten, so they put the light on the side, and you could see a snowflake perfectly, and it's using dark field illumination. I never told them what dark field illumination was, but students, and now I'm doing this with teachers now, teachers will do dark field illumination faster than I would at a compound microscope in our lab, because there's not, I don't know where the buttons for it are, and a lot of compound microscopes don't have that as a setting. So it's exciting to see people learn how to use these and do their own thing. That sometimes is, advanced illumination kind of things. Okay, so I made some of these with the students, and there was a teacher at my kid's school who I really admired, was a fantastic teacher who was really interested in science. And I thought, let me show one of these to her. And so I went to my local school and met with the teacher, Emily Kochi, who was a 3rd grade teacher for my older son, and then had become a science specialist for the school, sort of did science in a lot of the different classrooms. And I showed her one of these, and she just, her eyes almost popped out of her head. She got really excited about it. And she said, these are fantastic. And so she really wanted to use some of them. And I said to her, I said, will teachers use these besides you, or is this the kind of thing that schools would use? And this is just sort of a summary of what she said, right? She said, this is awesome, but most teachers will never use them. So I think I was lucky that I had a teacher who was going to be honest with me. And I felt like I could have an honest conversation about this kind of thing with. She said, the problem is teachers have all kinds of things that they have to do. Now and then something exciting comes to them. and they have to figure out how to fit that in given all the things they already have to do. So she said, in North Carolina, as in most states, there's a science curriculum that teachers are expected to cover. And unless what you bring them helps them cover what they need to cover, it becomes one more thing that they try to pack in that's hard to pack in. So I can use Google. And so I looked up the North Carolina science curriculum for elementary schools, and it turns out it's all sitting online, right? So there are pages and pages of what the teachers need to cover. And when I looked at these things, I thought, oh, these look really familiar. These are what my kids would come home and talk about. I remember my kids coming home in 5th grade and saying they're learning about cells or about skin. And in fact, the microscopes are really good for looking at cells and looking at skin, right? And in some ways better than the ways they were using, because the students could go outside and get grass and see cells or get flowers and see cells. And then they're learning about plants. They're learning about organisms and organism morphology and things like this. All these things that the microscopes were actually good for. I just hadn't thought that that's something that I need to really make clear to the teachers. So I now have a set of slides where, I know basically what teachers need every grade. So in 2nd grade in North Carolina, students learn about insects. In 3rd grade, they learn about skin and plants and how plants reproduce. 4th grade, they learn about fossils and adaptations, about crystals and about food, about chemicals and about food. 5th grade, they learn about cells. So these things are actually already well equipped for these kinds, for what the teachers need. And all I needed to do was make clear to the teachers that's what they'd be useful for. And so once I'd done that, Emily Kochi invited me to come back to the school. She said, would you come and show a bunch of teachers how to build these? And I realized because you can build them for about $10 a piece, I could actually, to build 10 of them was a little more than $100. And professors get paid okay. So I just bought the parts and went back. We had a dozen teachers. They each built a microscope. And now that school has a set of microscopes for the school. Now, this school actually, because it's near Chapel Hill, North Carolina, it was a reasonably well-funded school, and local Chapel Hill funds had put in extra money. Basically, parents had contributed. And so they had a set of microscopes. But when Emily showed me those microscopes, there were dusty old ones, missing parts. There'd be no oculars on some of them. There was a cabinet with some of these. Most elementary schools wouldn't have microscopes at all. I actually like these microscopes better for reasons I'll tell you in just a moment. So she sent me pictures, and I just blurred out the faces. So you're not seeing the actual kids, but you can see the kids are surrounding these things. They're really leaning in, and they're interacting as they're looking at things. This is a really different experience than I had when I first looked at microscopes in labs, right? My experience was I would look down these two tiny holes. I would only see my own eyelashes, and only I would know that. And so I'd copy my friend's lab report, and what I saw, I was not so much talking with other people about what I saw. Here you can see multiple kids are seeing the same things at the same time. And by some quirk in North Carolina, for whatever reason, a lot of schools that don't have enough funding for a lot of important things do have a set of iPads, because iPads were distributed all over at some point for them. So they put iPads on them. I should say the original design was adapted for a phone. I made them bigger, and I added some springs and some non-slip pads in the bottom. So we made just some minor changes to the original design. And I made them bigger because Emily had told me when I said, these are great because you can just put a smartphone on them, and smartphones are everywhere. She said, I'm the only one with a smartphone in my classroom because the young kids, at least at the time, didn't have them, but the iPads were available. So we made them big enough for iPads. So you can see there what's going on. There's one face I didn't blur here because it's my own kid she sent me a picture of. And you can see he's filling out a worksheet. So the teachers had actually put together worksheets that would fit with this activity. I have not yet put together worksheets myself because teachers have done enough of that. But at some point, I'd like to collect some of the worksheets or build some new ones to make it even easier for teachers to use them. Okay, so this built, the teachers built then a dozen microscopes for the school. And in that process, I learned how I could be helpful in a school doing this kind of thing. And the workshops that I do now are basically modeled after what we set up then, and some new lessons I've learned. So this is like what I actually project when I go to a workshop. I usually run 90-minute workshops for about 12 to 20 teachers in a school, which means they're going to have 12 to 20 microscopes for that school. And I usually schedule these with teachers to do after school, right at the end of the day, which bless those teachers, they've spent the whole day with 20-something, 30-something kids as active as my own. And then at the end of the day, they're going to stay and do this for 90 minutes. I'm always amazed that they'll do this. So what they do is, you can see three things here. First, they're going to build a microscope. I like that they assemble the parts themselves because it gives them some investment in what they have. They have something that they love, and is that, you know, quite often it's for their classroom, although sometimes groups of them will move to a single classroom. Second, they're going to take photos and share them and become a pro at using their microscope. I bring nothing from the lab except tardigrades, because everyone wants to see tardigrades, water bears. But almost everything they look at, they bring themselves, and that helps show them that you can explore science without it being something that's delivered to you and it's very expensive. A lot of teachers have told me then that students will often bring their own things. They'll bring in things from home they want to see, or they'll come in from recess and want to look at things. And this, to me, it's sort of, you know, the dream is that students would realize that you can, you know, the gap from being curious about something to doing something scientific can be actually quite short. And that's you know, what we hope. And then third, I always reserve about 10 minutes at the end of a workshop for the teachers to swap ideas about how to use the microscopes with the students. They're the experts at how to use them with students, and I just arrange it so that at each of the tables that groups of teachers are at, I'll ask them to brainstorm ideas, and then we'll share an idea from each table, and a conversation starts that way. So I project this at first. I project a parts list, and I leave all the parts in their original boxes from the hardware store. So almost everything here, except for the lens and the light, are available in hardware stores. This shows them clearly that they can make more if they want. And quite often, they'll go ahead and make some more. And then I show them this assembly diagram that I put together. I remind them that it's like an IKEA assembly diagram. It's one picture sort of that shows you a lot in one go. And then I'll just walk around the room while they're assembling them, interact with them. You can see this is pre-pandemic. We don't have masks. But I'll go around and help where there's any confusion. They'll put them together, and then they'll start looking at things. And so here's a teacher who's looking at paper money from another country. I think it's from another country. Paper money is really interesting because the most printing you see in newspapers or magazines or something is made of tiny dots. Paper money is etchings, and the etchings actually have really fine detail. And so it's interesting to look at under a microscope. I like to look at things that are biological and things that are not biological. And then at the end, when they brainstorm with each other for ideas for how they'll use these with students, I then collect those ideas and I put them together. And then once they're done brainstorming, I'll show them some of the ideas that people have had. We'll talk a little about them, and then I'll tell them there's a lot more at the website. Okay. The one thing that's, I think, important to know about this is the teachers absolutely love it. Like, those are genuine smiles. I think, you know, it's interactive. It's hands-on. I think it's, you know, they sort of expect something boring to arrive, and then it's not. And that's exciting. This school, by the way, is one of the schools in North Carolina that I was excited to visit. It's the grade school where Kizzmekia Corbett went to school. And if you don't know who Kizzmekia Corbett is, you need to Google her as soon as this is done. Okay. She's the EE Just speaker for the conference this year. I've tried to get out to more schools further away from where I live. And I had some of that working well with, there's a museum near here, a children's museum, where they would have teacher workshops. It was sort of in their mission as well to do similar kinds of things. And so I did workshops in the museum. Teachers would come in from Chapel Hill and Durham. And then the museum decided to put up a bunch of the pictures that teachers took as like decorations in the museum, which was kind of cool. Okay, so, you know, we've built a lot of microscopes this way. So there are hundreds so far. This is definitely not on the scale of Foldscopes, which many of you may know. That's sort of in the million kind of range. I think Foldscopes are better in one way that they can make an awful lot of them, and the resolution is higher. I think, at least in my hands, these are better for ease of use and sort of transparent. You know, it's literally transparent, so the use is transparent. And so second graders, third graders, it becomes intuitive how to use them in moments. But as I did this locally, I realized, my kids are in a reasonably well-funded school, but that's not true all over this state. And so I wanted to get out to other kinds of schools, right? I'm bringing sort of a gift, something to share with schools. It's going to feel a lot better if I'm going to places where the need is greater. And so I asked Emily Kochi again what she would recommend for getting out to other schools. And she said, there's a statewide conference every year, and you could present at the statewide conference, and then teachers will beg you to come to their school once they've tried this at the conference. And so I asked her to join me, and the two of us presented at the conference. And she's now moved somewhere else, but I now do this annually with my lab. And we have workshops with about 40 or 50 teachers where they each build a microscope. They're coming from all over North Carolina. Some of them are teachers, some are science or technology specialists in their schools. And then I offer to follow them home if they come from high poverty areas. And I'll tell you how I define that in just a moment. And so I end up doing a bunch of workshops every year this way. I was doing about 5 or 6 workshops a year. I want to get that up to about 10 a year now, because we're starting to do assessment of the program as well. Between this and actually visiting schools, this has gotten a lot of microscopes in a lot of places, right? So North Carolina has 100 counties, and I've gotten microscopes into almost half of them. But most of these are just a small number of microscopes sort of seeded, where now I can hopefully go back and do a full workshop where a school can be outfitted with a set. Some of you may be aware that the funding level for schools does not track need very effectively. In fact, to some degree, the places where the need is greatest is the places where the funds are lowest, because funds sometimes depend on local property taxes, which seems criminal that this is allowed, but a lot of states still allow this. So little by little, I'm trying to become an expert in school funding to figure out where is it that I want to go. And I've realized that if you really want to know where the students have the most need, there's sort of a per student metric, which is the free or reduced lunch percentages. So most states have these data sheets you can find online. We can find what proportion of the students are getting lunch for free or at reduced rate. Actually, during the pandemic, most schools went to 100% free, but that's probably going to go back to how it was before. So I use this data, and I tell teachers that if your school has at least 75% of the kids on free or reduced lunch, which is a shockingly high number, that I will promise to come out to your school if I can. And I travel around the state this way. I get to places I never would have been otherwise, and meet people that I probably wouldn't have been able to talk to otherwise. And that's been exciting. Okay, so last things I want to say is, first, this is a really satisfying thing to do. I don't do these directly with the students. And the reason I don't do them directly with the students is, well, first, I get a little nervous in a classroom because I'm about 6'2", and I have like Gulliver's Travels nightmares. But the other reason is I realize the teachers are the experts at working with the students. It would be sort of satisfying to work directly with students. But if I can show teachers how to do this, this can be really effective, right? An outreach project you do with teachers can reach a heck of a lot of students. And this is just, a graphic, rough estimate of how many students would be reached from one workshop. And that's how many would be reached each year, because they use the microscopes from year to year. So it can have really an impressive impact, I think. The other thing is, if you have an exciting outreach project that you think is working well, there's no reason you have to do it alone, right? So what I do now is I do a poster on this at ASCB some years, and at other kinds of conferences. And anyone who seems really interested, I offer for them to do the same by coming and visiting one of my workshops, learn how to do it, and then they're equipped to do it themselves. So here's just one example. Pablo Silva Rodriguez, sorry, I misspelled his middle name there, is from Georgetown University. And he's been doing workshops in El Salvador, in the mountains, in high poverty areas that have been fantastic. The other thing I do, because I want to be able to share what I'm doing with other people, is I keep a parts list online. It's very easy to set up a spreadsheet that will populate a web page where this is continually updated. Anytime I have to find a new place to get my parts, I update them here so anyone else can do the same things. Okay, I just want to come back now. You were advertised a webinar that would accomplish these things, right? How to incorporate hands-on activities in science outreach. And I think, we've just talked about one example, but in the second half, you'll probably hear a little bit about some of the other examples from the panelists. Second, how to adapt science outreach activities to different groups of audiences. I did this first with my own kids and then with teachers. And then I also teach other scientists how to do it by showing how to do it at conferences. And then last, how to get funding for science engagement events. That was probably the least satisfying part of this webinar so far, right? I told you I took money out of my pocket and just started paying for stuff. I get, my lab is funded by both NIH and NSF. And NIH, it's hard to get funds for this kind of thing for, but NSF, they love this, of course. Many of you probably know NSF grants require an outreach component. And on NSF panels where I've reviewed grants, I've noticed that panelists can get really engaged by an exciting outreach event, right? So an exciting outreach project. So outreach projects are required, and I think a lot of the outreach projects are just fine, they're okay, but now and then there's one that'll capture people's imaginations, and I think it can actually propel a grant to help get it funded. Okay, so I'll stop there, and we can go on to the second half.
Great, thanks, Bob, for this wonderful talk. I think we learned a lot from your exciting experience, and it's really cool to see how many schools and teachers you reached. That's wonderful. And then we'll start for the second half of the webinar. And to kick off the panel discussion, I would like each of our three panelists to describe a little bit about your own outreach project and how you think your project can kind of relate to what Bob just talked about. Just maybe one thing you can think about for now. So Quinn, do you want to go first?
Sure. So my name is Quinn All. I'm an associate professor at Gannon University in Erie, Pennsylvania, and I was one of the first awardees of the Public Engagement Grant. And what I got awarded a grant for was to start an after-school program called Feeding Minds and Families. And the idea behind the program was to address two big issues. One was that there was a lack of, I was working in a low-income area, there was a lack of after-school programming, and then secondly, to address the gap between students participating in after-school activities and parents being involved. And so I wanted to do something that incorporated both. So it was an after-school program where students would do activities, but then afterwards we would actually have dinner with the entire family and get to know them, and it would actually provide some, one-on-one time that the parents could have with their kids. It's what the activities that we do are geared more towards STEM in general, so not just biology. So we touched upon all aspects of science, technology, engineering, and math. And I would say probably the most successful activities that we've done are the ones where they really help kids to see that anyone in those fields, they are not siloed to each other, that they are actually very well connected with each other. So for example, we had done one actually that was the sort of talking about what's the connection between music and physics. And this was one where the kids got really involved into, some of them had instruments, they started, examining that. We've done sort of a forensic case, sort of what are those, escape room type of thing. The kids really, really like that. So anything where, you can show them something, but show it in a bigger context, the kids really seem to enjoy that. So that's one of the things I do. I also run a service learning course this semester where we're working with another after-school program where my undergraduate students are developing curricula and activities for middle school and high school kids, and we're actually calling it junior biologists. So they get to come to our labs and do science experiments, and they really love that. And then the third thing that I've done is I've tried to adapt activities to put into subscription kind of STEM kits. And this was especially during the pandemic when pretty much, we couldn't do any in-person learning. I wanted to try to figure out a way in which we could still get some activities to kids to be able to do in their home environment. And so I ended up working with a couple of engineers to develop STEM kits where we explored things like climate change. We did one actually on infectious diseases. So those were really successful. So.
Thanks for sharing, Quinn. That was Really good to hear about your experience. Molly, do you want to go next to talk about your project?
Sure. Hi, everyone. I'm Molly, and I'm a PhD candidate at Johns Hopkins. And I also was a recipient of the 2018 ASCB Public Engagement Grant. And I was funded for a project that I thought of that's called Science Outside the Lines. So it's an after-school science outreach program that marries the idea that science is creative by working with both art and science. So a group of us, graduate students and postdocs, work together with a local non-for-profit art program in Baltimore. And this is all like down in the East Baltimore campus. And we come up with some topics that we're interested in as scientists. For example, we have like cell biology and neuroscience, and we also stray from strict biology, like we do some chemistry and engineering. And then we work before the class with the art program to come up with an art project that complements the idea that we want to teach for the science class. And the idea there is just to make like the idea like a little bit more hands-on and less rigorous and more exciting. And I think it's been really successful. We're really thankful for the ASCB funding. And in terms of how it relates to what Bob was talking about, like we're also working with the same age students, but we work directly one-on-one with the students. And I think it's a fantastic idea to like perhaps leave these lessons with the teachers and even have like even more of a reach. They can teach their classes when we're not there. I think that's a really good idea that was mentioned. And finally, to his point of, for example, like thinking about how these grants will affect like funding sources. I actually had the idea for Science Outside the Lines as I was applying to the NSF GRFP through that broader impact section. So I was really like trying to challenge myself and think of like what type of broader impact I want to have. So that it is true that it helps make your grants a little bit more creative.
Sounds great. Thanks, Molly. Then Kristin, do you want to share your experience?
Yeah, I'd love to. So I'm Kristin Kirschbaum. I am the director of the Instrumentation Center at the University of Toledo. And 12 years ago, as part of my job, I wrote a grant for a scanning electron microscope, NSF. And as we mentioned already, NSF is very interested in outreach. So I came up with the idea, why don't we go to schools and let students in the school use our scanning electron microscope using remote control software. So that was 12 years ago. It was pretty difficult in the beginning because schools and software, they don't want students to use the computer and things like that. We have it pretty much straightened out by now. We always have to be one step ahead of IT security because they suddenly don't allow us or the school to use it anymore. So we have already the next program lined up in case they suddenly forbid it. So what we do is we go to the school. The schools in the classroom, they have two big screens. One screen is directly remote controlled software. So the students in the classroom use the instruments as if they would be on campus. On the other screen has a scientist in the room. The scanning electron microscope is a huge microscope. It's in one room. So there's a scientist there who talks with the students, interacts with them, puts the sample in. Everything else the students do. That students can change sample, they move up and down, they focus, they take pictures. There is a detector that can do elemental analysis. So we have one unit, which is kind of who has done it unit, and they analyze different powders and figure out who was the murderer. We have since added a confocal microscope, spinning disk microscope, gas chromatography mass spectrometer, FTIR infrared spectroscopy we are doing next week, I think. So this is, so far we have reached over 5,000 students over the last years. One really nice thing, there's a nice thing about COVID. So last year, we couldn't go to the schools anymore, obviously. So we changed the whole program and it's completely online now, or we do both right now. But during the whole pandemic year, we did run this program completely online. We had students on Zoom in their bedroom running on their cell phone our instruments. It's a little bit more tricky, but it was fun. One thing we noticed is several times, actually it was almost the rule, the students asked to stay longer. They didn't have the strict schedule anymore, so they could stay longer. Can we just look at this sample and that sample, and can you stay an hour longer? It was almost the rule. Not all of them, but half of them stayed for another hour quite often. The other good thing that came out of the pandemic is that we expanded from local school areas to, I think we have 13 different states. I'm in Ohio, we did New Mexico, New Jersey, Rhode Island, California. We have one request from Australia, which we already tested, the connection, it worked. We haven't had the session yet. So that's actually a suggestion for Bob. Can you consider making your workshops online so you can spread out further? You don't have to drive. Yeah, I think that's it.
Yeah, I can address that. I think the teachers, one of the things the teachers really like is they meet a scientist, a university professor from a biology department. And I think that sort of connection they like. That I was a little nervous at first that I meet so many teachers doing this that I would be getting constant emails with questions, but they tend to be very good about that. And then I have on occasion mailed ones away with instructions. I've done some online. I think there's nothing like being there in person.
Oh, I agree. In person is better, but.
So I made sort of the strategic decision that if this was working as well as I hoped, and we're doing assessment now to actually assess if some of the, the dreams I stated are actually true, that what I would do is try to spread it by just encouraging other scientists to do it as well, because it's something that almost anyone could do quite easily. And I do it in one state. There are 50 other countries. So, but that's a different kind of approach. How exciting that students can use really high-tech equipment that way.
Oh yeah, it's a lot of fun. And we have, I think the youngest were 3rd graders, and we go up, of course, to 12th graders, but we also have community colleges. So yeah, just adjust the topics.
Thanks, Kristin, for sharing. And now we'll turn to some audience questions for now. And for the audience, if you have further questions, feel free to put it in the Q&A box. So I think some questions are directed to Bob for especially about making the microscope, like what kind of lenses would you use, some other ways of easier, cheaper ways to do the lens, or how much it costs to and how long it takes. Just some general, maybe a general rundown for your workshops.
Yeah, I'm glad people asked because I didn't mention much about the lenses. So the lenses, this is one of the lenses. It's a tiny little lens. And this was Kenji Yoshino's clever idea in his original Instructable. He realized that cheap laser pointers actually had a lens in them already, and he just sort of dug one out of one of those. But you can buy those lenses separately. This is actually the kind of lens that they put into most cheap. If you open up a cheap laser pointer, you will often find this exact lens sitting in them. So at first, people were sort of buying cheap laser pointers and throwing out most of the parts except for the lens. But you can buy these online. There's a company in Texas that sells them for $1 a piece. Unfortunately, the person who runs that company sent me the wrong kind of lenses for 2 of my last 3 orders, which were 100 lenses at a time. And so I think I found where he gets them from, which is I can get them from China on AliExpress for about 50 cents a lens. So I placed a small order to make sure they were the right lens. They were, and I ordered 500. So I'm set for lenses for a while. And you can for sure do some of these things cheaper. There are ways to make cheaper lenses, but I'm down to really about $7 or $8 per microscope for costs now. And I think it's low enough that really the bigger concern is how I can get out to enough schools. And part of that is just uptake from the teachers, right? So teachers love doing this, but they don't necessarily know that until they've done it once. So getting to the statewide conferences has been important for that. Cost has not really been an issue. Yeah.
Sounds great. Thanks, Bob. And I think there's a very interesting question from the audience about how would you assess whether your outreach projects are working over time, what metrics, for example. So would the panelists like to kind of give their ideas also on that topic?
Yeah, I
Shall
can
I?
start.
Okay, go ahead.
Yeah, so through the ASCB Public Engagement Grant, we actually got matched with these mentors from an organization called like Lifetime Learning Group, and they were like having specific training in formal evaluation. So some of us, I think everybody probably got matched with them, and we got to learn like different ways of doing these formal evaluations, and like using things like logic models to really understand like what type of questions we wanted to answer. And so like for me, since I was working directly with the kids, I really wanted to make sure it wasn't a survey or a test or anything, because they get enough of that during the day. And so for our like formal evaluation tool, we had these like handouts that went with like each of our lessons. And on the handouts, we had some like games for them to do and some place to take notes. And then also on the back, this was really part of the formal evaluation tool. Sorry, it's not showing up here, but it was a thought bubble. And it's kind of this like, I really want to know ... where they kind of fill in the blank. And we were trying to just have this as like a natural extension of the lesson. Like while we were giving the really short, brief PowerPoint slides, they could doodle on this. We really encouraged doodling as well as note taking. And I actually like manually looked through these and like coded this as the data for assessing the question. The one that I was really interested is, were we like inciting curiosity and having the students ask questions beyond what we were just teaching? So that's one option for a formal evaluation tool.
For our program, so what we did is we had a lot of volunteers that were helping out, serving meals and stuff like that. So we kind of got indirect evidence where part of the activity was the volunteers would go and talk to parents and kids, and then they would report back what they learned. I think like one of the big things about evaluation is really being very specific about what you're trying to evaluate, because you have to know ahead of time what your goal is. So like for my outreach activities, my goal is not to teach them necessarily a science lesson. While that is important in the area that I'm working in, it's really about engaging them and getting them interested and curious. And so what I always tell the mentors that I work with is that, if they don't get it 100%, that's okay. But if they're still interested in what they're doing by the end of it, that's a big win for us. So I think like that's one of the things, like, when you're taking into account evaluation, you need to understand is like, okay, if your goal is learning, then make sure that that's how you model your lesson plan. But if your goal is not learning, then don't assess learning necessarily.
I guess I'll add, since we're doing assessment as well, I'm working with someone in the School of Education at UNC, Kelly Ryu, who's an expert at this. And she is organizing this to basically assess the things that I had an intuitive sense were working well, to see, is it really the case? Because I only know this sort of anecdotally from talking with teachers. So one question we have is simply, a year or 2 years after a workshop, where are the microscopes physically, and are they being used? That's a straightforward thing to assess. And then the long-term goal is, like I said, that we want to make the gap from being curious about something to doing something scientific as short as possible, so that kids exercise their own curiosity and look at things, right? So I'd heard from teachers that kids will come in with stuff from recess to look at, or they'll feel something, and a leaf will feel fuzzy, or it'll feel fuzzy like shark skin, where it's only, it sort of grabs them in one direction. They get curious about why, and because they've used the microscopes, they bring them in and look under the microscopes and, do some hypothesis testing in a way, right? We're assessing by going back to the teachers a year or more later to ask them, did that happen? Did kids bring in things that you never told them to bring in from home or from recess? And then we're doing the questionnaire to get quantitative data, but we also are going to do focus groups to get a better sense of, what does all that quantitative data really mean, to talk with them directly. And the goal is to be able to test whether we're doing things well enough and to improve the workshops. That we may find through this that we could be doing things a little better.
Yeah, we also learned, thanks to the ASCB grant, how to do a logic model and how to assess things. But our result is a bit more traditional. It's a very short questionnaire online. And the questions are, we only have 45 minutes on ours. So questions are more worded like, after the session, do you have more interest in science, or are you being more excited about science? And that can evaluate between 1 and 5.
Sounds great. Thanks everyone for sharing. And I think there's another interesting question from the audience about using online workshops for teachers outside the US. Do you guys have any ideas on that? Or would just hands-on activities be mostly what you're doing? Oh, Kristin, go ahead.
No, actually, I wanted you to, could you repeat the question, please?
Yeah, sure. So do you guys know any online programs that teachers internationally can also access?
Well, ours is online. If you go to Scope University of Toledo, we have it set all online now. So it's called Scope, like microscope.
I see that one of these questions was specifically from New Delhi. Manu Prakash has done an amazing job with the Foldscopes in India and lots of other places as well. I've done these kinds of things mostly by, if people want to come and come to the workshops, if scientists want to come and learn how to do it in other places, they go do it in other places. And there was someone from Sri Lanka, but I haven't had anyone from India yet. If anyone wants to come, of course, I'm only too happy for someone to join in a workshop. And after doing one workshop, I think they could be well equipped to do the same kind of thing wherever they like.
I can also recommend to check Facebook with all its problems. This is where we announced our program, the biology and chemistry teacher group. And we get a lot of requests because I see it on Facebook. So other programs, of course, do that as well. So you might be able to find some there.
Sounds great, thanks. And I think there's a question for Molly, I guess, specifically what else did the thought bubble have for that specific activity you did?
Sorry, can you repeat what you said?
It says, what else did the thought bubble have? I guess what's in there for a little bit to finish that.
Yeah, so the thought bubble itself just says, I really want to know ... And that was just the idea for students to come up with. We were really for the actual formal assessment for that part. If they actually wrote something that was a question, I scored it as that we have incited their curiosity to the point where they asked a follow-up question. Does that answer the question? They just want to know about the thought bubble. The other part of it is, so one question for my evaluation was curiosity. That's a thought bubble. The second part was engagement, because we wanted to know whether or not they were engaged during the lesson. And in order to understand if they were quote unquote engaged, we had a little game that we put on here. So for this one, we were teaching about insects, and we did a project where we made recycled insects. So this was a mashup between studying insects, morphology, as well as a bit of engineering and also environmental science with the recycling part. And the little game would include something like labeling whether or not this little insect or arachnid that we put here, tell us whether it's an insect or an arachnid. And we actually, to the point that others were making, is because this is an after school program, we I personally was not as interested in following like very rigorously the exact knowledge that they learned and whether or not it was right, but more like were they like doing something after school to keep them engaged, and also like actively doing both art and science. Also to the point that Bob brought up, we cared a lot about like what the Maryland curriculum for science and art, what they were both aiming to cover. So we tried to like weave our lessons like within those lines to hopefully like supplement what they were learning in their classes, and hopefully have some of the teachers more like on board with what we were doing.
Thank you, Molly. And I think there's a comment from the audience about Bob reaching out to many schools and students. So I guess maybe all the panelists can also talk about how you first decided to approach to the students on your activity, and kind of how you spread more to more communities, more groups, some maybe your experience and maybe challenges in this process. So yeah, Quinn, go ahead.
So I started with one school that my university had already had a partnership with. And that was, we worked pretty much exclusively in the urban area in the city of Erie. And so they had this model, this community school model, where they wanted people from outside the community, outside the school, to actually come in and do after school programming. So we started there, and then that led us to some of the other schools in the area as well. And it was really like a lot of like word of mouth. Once our program started gaining some traction, like the other schools wanted it as well, and they wanted to do, they want the STEM kids. So we're sort of, it's a lot of it's sort of word of mouth and building that trust. So once, you know, you've done the program a couple of times and, you know, you get that trust built in, then I've had people come and talk to me about like, well, can we start something outside our school or a charter school or something like that?
Yeah, so I took the approach also for just starting with one school that my biggest goal was like ease of myself being able to volunteer here. So it's within walking distance of my lab, and luckily they were just welcoming us with open arms to have more engagement with their students. And I have not expanded to any other schools, but one successful like way to expand that's not necessarily establishing the program again at another school is just within your, if you guys are at like universities or in your own departments, like if you see that there are other people doing other outreach events, or what, like maybe it's like for example a STEM night at a school or something, like you can take one of your more successful lessons and you know, like have a little booth at an event like that. And that, we've done that quite a bit. So in other words, like collaborate as much as possible with all the other people in your department who are interested in doing outreach. And that in itself will help like change the academic ecosystem at your university and make it so that this is more of a regular event, and that everybody in your department is wanting to get involved.
Yeah, we started, or I started similar to Bob. You start with your own kids. So the first kid using the scanning electron microscope in person was my son, who really went into it. He checked his algae from a saltwater aquarium and figured out where there are more diatoms, and so he totally went into it. And then his school, our challenges were suburbia schools were easy. Getting to the big Toledo public school system with 20,000 students was quite a challenge. There was one teacher who was very interested, and then we had the IT problems at one point, security problems. So the way to overcome it was that I sent an email to the superintendent and saying, all these suburbia schools using our program all the time, I don't want the public school system to be left behind. And follow-up emails, I always copied the superintendent on it. So we are doing it now. IT is working with us, gives us permission to use the computer. Yeah.
Great, thanks for sharing, everyone. And I think we're getting very close for time now. And I think there are some questions we might not be able to get. So feel free for you guys to contact our panelists and speaker later on. So as we kind of wrap up, could everyone kind of give some summary about your experience or just some general suggestions for people who want to perform this kind of hands-on activity workshop? So Bob, do you want to go first?
Sorry. Yeah, in hindsight, I realized that having a good connection with the teacher made a world of difference, right? We can come up with all kinds of cool ideas, and if we can't get them to teachers who really want them and figure out what are the real practical issues for getting them incorporated, it can be really challenging. And so I was just lucky that there was a teacher I had sort of a reasonable, just working relationship with from working with my kids. But finding a teacher who will give you honest answers to your questions as you're trying to develop something, it just makes a world of difference. It turned it from something that was just kind of a dream and seemed really cool, and I thought everyone will like this because it's really cool, to something that they actually could take up.
I would echo that as well. So in all of the programs that we do, we always have, we always work with at least one of the teachers at the school as kind of an advocate. And we always try to keep the perspective that, we're coming in on their turf. And so we have to make ourselves, make it clear that, we're coming here to serve you, and we know that this is your home and not ours. So
yeah, I guess we all know this. The good teachers make a very, very big difference in the life of the students, and in terms of making outreach happen or allowing us to do it.
Yeah, I will just add, you were asking for some words of advice for people. If anyone is still a graduate student or a postdoc, just know that even just getting involved in pre-existing outreach program is already like a really amazing step. And if you want to start like your own program, I recommend have like a group of people, like don't go through everything alone, because it will definitely help with like applying to the grants. And also, like, I personally feel like I benefited a lot from, I'm not just working with a local elementary school, but I mentioned this local non-for-profit who helps with like the art program. So get as many people from your community involved, and it really gives you a sense of like, you're not just a transient student here, but you're like hanging out with all these awesome programs within your community. So just don't do it alone.
I agree. We started with 2 people. I think we are now 15 who are working on this.
Great, thanks everyone for sharing your experience. And I personally have learned a lot for all the great work you've done. And I hope, I think the audience are also learning a lot from all your experiences. Thanks for participating in this webinar today. And sorry for some audience questions we might not be able to get to. I think for microscope related questions, you can find it on Bob's website, I believe. And it's also very inspiring to see many people who want to try Microscope workshops, which is really great to see. And thanks everyone for participating, and thanks for your attention and time. It's great to see you guys today. Thanks.
Thanks for inviting us.
Thank you.
Thank you.